Okay, the last part of this presentation is dedicated to the workflow of quality check of biodiversity informatics data. Okay, so you have the initial steps of, let's say, collecting data, formatting data, and yes, digitizing data, formatting data. Now, you need to check uh, the different attributes you need as workflow to have, let's say, data quality. You need to make some checks, some controls, some validation. Okay, and with respect to the taxon, you need internal consistency. Then you will cache duplicates and typo errors, and external consistency. Let's say consisting in checking the authorities, okay, the authorities who describe the species. We need also to check for time, internal consistency. Yes, some erroneous introduction, okay, and consistent dates. We need also to check for places, internal consistency for missing data, okay, test coordinate conflicts, for instance, and okay, you need to cross time to place to find out, to check the itinerary, for instance. You need also to cross the taxon in place, okay, to find out the distributional consistency, environmental consistency. Now, let us talk about the taxon, internal consistency and external consistency. Here you have a data I just download, and it concerns the animal of malaria. It was downloaded. I downloaded it on 7 December, okay, 2021, when I was, let's say, preparing the course. I tried to find out the different problems with respect to the taxon, okay. So for what I can consider as a consistency, let's say internal consistency, are here in, let's say, in green, okay, and the external consistency are, let's say, in yellow, okay. For internal consistency, you see here, you have the species abbreviata that is only identified at the genus level, so it is incomplete. We also the species abbreviata SP, that is the species not determined, so incomplete determination. Here, you have a species Acanthocercus atricolis and Acanthocerus atrocolis. So an error in the species name. You have Acantholides, that is the genus name without a species name, so it is incomplete. And also, you have here the name Accipiter trachiro sparsemfasciatus, and also the same name Accipiter trachiro sparsemfasciatus. You have S here, okay, this name which is absent in the previous name. And here you have, let's say, a name which is a higher rank. Okay, let's say, okay, the name of yes, it is a tribute. We call it tribute. The name of a tribute. Tribute. We call it the tribute. Okay, in French. It is a rank below the, let's say, the rank of the family. Okay, it is a higher rank here. Now, with respect to external consistency, we are here Abactochromis la brochure without the reference, let's say without an authority. We have also a Bactochromis, la brochure, but with let's say the parent name, which is the authority name, the one who describes a species. So the same applies to Abanthis zambesiaca. Abanthis zambesiaca. Okay, one is without the authority, the second one is with authority. The same applies to Acada viseriata and Acada viseriata mabile 1893. Okay, so you can see the let's say the problem of consistency when checking on the taxon. Okay, in practical exercise, I will let's say I will show you how you can okay how you can have an idea when display such errors. Okay, when you have a data set. Okay, let us now check about the dates. Internal consistency, incomplete date, and inconsistent date. For instance, for the days, it should range from 1 to 31. So the day in a month, either it is from the first of the month to the 30 or the 31. But we don't have day 0, for instance. But day 0 exists in the data. We don't have a day 47. It exists. And okay, these are errors. Okay, for that, those are errors. Okay, we should need to correct or how to say or eliminate the data related to that. Well, for instance, doing completeness analysis, when time is indispensable, we can okay discard those data. Have let's say dates that are ranged of day, which is not acceptable. So it's a problem format here in green. Okay, as you can see. As for the month should range from 1 to 12, not more. And you have month 0 here, for instance. Okay, and you have month 13. And also you have a problem format of month. Those are some errors, okay, we introduce in when we don't care really or we are not conscious of what we are doing. Okay, those errors are introduced. Okay, okay. Now, as for the year, internal consistency, incomplete, and the inconsistent dates for the year, for instance. Okay, we have year 0 here. To what it refers to, so it is erroneous. Year 106, okay, at the time of Christ. 0 is considered as the, let's say, the year of Christ was born, and 106 year, very, let's say, the first century. So it is not, let's say, it is erroneous, right? And as of today, we are, let's say, in the year 2022, but not yet 2037, 2061, etc., etc. So those are errors of introduction of yes, numerization. Okay, and those are range of years were not valid. The format is not valid here. Okay, so we need to check for that. Okay, we need to check for that. Clean the data before using them, right? Now, for the places, internal consistency, missing data, the test coordinate conflicts, etc. Okay, this is your country, you see, and this is the animal records, okay, published from your country, and okay, published with respect to your country that are supposed belonging to your your country. But you have outliers, all those occurrence points that are not inside the border of your country. So it is a problem here. It is a problem here. You need to clean them out, okay, to discard all of this. But those are the problem we have. Okay, when we cross the time with a place, we can discover inconsistency in the itinerary. So, from Peterson 2015, we have a map of collecting localities for, let's say, Philips. Let's say for the dates 2 to 10 October 1955, showing a locality in Guerrero on 8 October, so 2 here, 8 October, so the point 2, that is probably erroneous. So you can check the distance between the two and find out that during that week of data collection, when he collect data, okay, here, I have a point 8 also here, okay, I have also point 8 here, far away, far away, far away. Those are the dates. Okay, so the date on 8 he collect data here, on 2 he collect data here, and from 5 to 10 he was here, and also on 8 he collect data here, and also the same day 8 he collect data here. This is an error. Okay, and when you check for this, okay, it is erroneous, and you need to discard, for instance, the collection made on 8 and maybe on 2. We need to check the distance. Okay, with respect to task on times, places, distribution, consistency, environmental consistency. So it is the case of two close species of birds observed, okay, in a locality, but they are different. But the observer can confuse them as they are too close. So two different species in the localities with occurrences pointed in yellow related to this and in purple related to that. If you confuse them for ecological niche modeling, you will have a bad result. You won't have a good result for that. So this can also be applied to plants. Plant species, let's say those belonging to the same families or same genus, are quite, let's say, similar. You need to pay attention to them to find out the difference and collect the data and report them at the appropriate places with the appropriate taxon to avoid confusion and error in decision making with respect to the conservation of those species. Now, we will talk about the secondary biodiversity data. According to Peterson et al., there are summaries based on primary biodiversity data. An example is the distribution area. For instance, when you achieve ecological niche from the primary biodiversity data and the environmental data, you achieve the distribution, let's say the distribution, spatial distribution of species. The spatial distribution of a species is considered as secondary data, data derived from the primary data we use in analysis. The checklist as well. Okay, checklist, I will come back to that. And checklists are considered, that is the list of, let's say, the list of names of species. Checklist as a list of control. And we have a description of the natural history of species, for instance, which is considered as secondary data. Now, checklist. There are resources comprising a list of the species belonging to some categories. For instance, taxonomic, geographic traits, trait base. A taxonomic, we can consider, for instance, I don't know all the species present there in Malawi, but maybe there are also Verbenaceae species. Okay, if you consider the species belonging to that taxonomic family, Verbenaceae, the geography of the north of Malawi, for instance, can say, okay, the species of the north of Malawi, or threat-based, that is species, for instance, on the list of IUCN Red List, crop wild relatives, whereas the parents of the species that are cultivated now, and optionally with higher classification or the additional threats associated with each of them. You can also have combination of them. For instance, Verbenaceae species of the north of Malawi, of a threatened species, okay, of a family of Verbenaceae, a threatened species of the forest of the north of Malawi, etc., etc. Okay, you can example of such lists is on catalog of life. Such catalog life, regional or global taxonomic checklist. Over than on catalog of life, over than 2 million accepted species are as of let's say 30 December 2021 when I was preparing this course. Okay, the release is that on catalog life sheet you have more than 2 million of accepted species names. Okay, you can have also global or national red list on UCN seat, for instance, where you have more than 40,000 species threatened as of 30 December 2021. Catalog species included in the digitized collection. I talked to you about the on digitized collection 2.5 to 3 billion of specimen data in natural history collection and in museum. And only 10% of this, as of today, okay, less than 2 million of the data on GB sites, less than 200 million of the data on GB sites are from preserved specimen, that is from, let's say, museum and the natural history collection, out of 2.5 to 3 billion of specimen records. So the challenge is still very, very huge, and you need to contribute. You are to contribute to that through data collection, through data cleaning, through data publishing. Okay, what is metadata? Metadata are structured description of data set. When you have a data set, it is important to you to document the data set, to describe the data set. But they provide essential details such as the geographic and taxonomic scope of the data, the method of collection or observation, the context and citation requirements. They help contextualize data sets, and they allow users to decide whether the data is suitable for use in the research project you have in hand. And it is important to document the data set you have in hand. And what is good to say is that you cannot publish a data set on the website without metadata. It is important. So, right, it is important then to document your data, right? So, this is the end of the presentation. You have the references I use in the text. Okay. You can go and yes, look for them, read them. I encourage you to read them, okay, to improve your knowledge. Okay. Those are my contacts. Okay. And thank you very much.